Welcome to the end of the world. Antimicrobial resistance is one of the biggest threats to public and animal health worldwide. In 2017, the World Health Organization published its first ever list of 12 antibiotic-resistant bacterial families that it deemed priority pathogens. The bacteria on this list were infections that we used to be able to treat easily, but are now becoming harder to do with the increase in multi-drug resistant bacteria and a dwindling number of options. Antibiotic resistance can occur naturally, but due to indiscriminate use of antibiotics, this is rapidly accelerating the pace at which resistance occurs. Most bacteria will die, but some mutate and become much harder to treat. Emerging organic contaminants are natural or synthetic chemicals found in household products, pharmaceuticals, and agrochemicals. These chemicals have the potential to cause adverse ecological and/or human effects through their usage. Our environment is key in the spread of antibiotic resistance, with increasing quantities of emerging organic contaminants released via stormwater, agricultural, municipal, and industrial waste effluents. Influx of these contaminants into waterways can create hotspots that provide a selection pressure for the bacteria to mutate. Our research is to investigate whether emerging organic contaminants can promote antimicrobial resistance in the environment, and if they do, which ones are of most concern. Once identified, the long-term goal is to elucidate the mechanisms of resistance that are used, and to highlight priority chemicals whose use should either be banned or carefully controlled. In a laboratory setting, 5 emerging contaminants, triclosan, triclocarban, diclofenac sodium salt, carbamazepine, and fluoxetine hydrochloride were screened against 5 bacterial species: Enterococcus, Pseudomonas, Staphylococcus, E. coli, and Salmonella. Each bacteria was exposed to low-level concentrations of each emerging contaminant and then tested against clinically relevant antibiotics to look for changes in antibiotic sensitivity. All bacteria exhibited tolerance to triclosan, which resulted in changes to antibiotic susceptibility. The same occurred for all bacteria that were exposed to fluoxetine. However, all bacteria were tolerant to triclocarban, diclofenac sodium salt, and carbamazepine past the water solubility of those chemicals, so no further testing was completed on those contaminants. In conclusion, exposure to emerging organic contaminants can induce or select for bacterial adaptations that result in decreased or increased susceptibility, and so far the biocide triclosan and antidepressant fluoxetine are the tested organic contaminants of highest concern.